Hi everyone, hope you are doing fine. So today we are going to solve the weekly contest 508. So I am going to solve the second and the fourth problem of this contest. So let's start with the second problem. So second problem is filter occupied intervals. So in this problem, but read the problem. You are given a 2D integer array like occupied intervals named as where it has two variables like start and end I represent the time interval during which you are occupied, and each interval starts at start I and ends at end I inclusive. Like if the interval start at 2 and end at 5, it means that 2 and 5 are also inclusive in that interval. Like at that time we are occupied, and we are also given two integer, like we have also given two integer name as free start and a free end, which define a free time interval from like a free time interval, like from free start to free end. We are free in that time. We don't do do an interval. So our task is to merge all the occupied interval that overlap or touch, and then remove all the integer points in the free interval from the merged occupied intervals. So it is mentioned that like if the two interval 1 comma 1 and 2 comma 2, like they are touched, like you can see that 2 is started immediately after the second, so they are touched. So also we have to merge these things also, and after that we have to return the remaining occupied interval in sorted order. So let's see the problem by taking the example. So yeah, so yeah, in this problem so we have given something like occupied interval. First, like we have something like points like 2 comma 6 comma 4 comma 8, 10 comma 10, 10 comma 12, and 14 comma 16. So these are the 5 points we are given, and we have free start at 7 and free end at 11. So yeah, let's see. Like, so first thing is like we have to merge the interval. So like this is a classical problem. You can see you can find around hundreds of question of this type on LeetCode. So we have to merge these things. Like, so you can see like 2 6 and 4 8 can be easily merged because they are overlapped. You can see, so it will combine to make it will look something like, we are after merging it will look something like 2 comma 8, and after like 10 10 and 10 12 it is also overlapping, so we have to merge this thing also 10 12, and the like last one is 14 comma 16, so it will remain as same. So yeah, you can see that after our merge the overlapping intervals, we get something like this. So now what we have to do, we have to simply remove the like interval which contains like which are overlapping with this free start and a free end. So yeah, so now we have to remove all the interval, like let's assume we have given a as, let's take this free start as a and free end as b. So we have something like we have given a comma b range. So in this we are free and we cannot do like process an interval like this, you can assume like this. So yeah, so there will be a four case, like to think about this, there can be a four cases. Like if we have something like start point comma end point, uh there may be a possible like s mean start and e mean end point. So there may be possibility like start comma end point completely lies inside this range a comma b, which is our like in which we can't do anything. And another case is like our start comma and will be greater than like this range. And another possibility is like we have something like we start before a and at something like this, and last one is something like this, start at this point and at this point. So yeah, these are the four cases which can happen. So yeah, so if you get this thing, like there are only four possibility, then it will be easy for you to solve this problem. This is the main thing to know, like to know about in this problem. So yeah, So let's see how it work, like what does it mean. So like let's take example, like we have given us a as 7 and b as 11. So you can see a as 7 and b as 11, and we have to process something like s is this, and e is 8. So you can see that 2 comma 8. uh let's draw this thing again here. Like we have something like 7 comma 11 range, like a is 7 and b is 11. So we have to process this point to check if it lies in this range or not. So it will look something like 2 comma 8. It will like overlap like this. So we have to remove this this part. We have to remove the part which are overlapped with this time. So it will become like 2 comma 6, because the interval is inclusive, so we cannot include 7 in our answer. So at end we will get answer like 2 comma 6. So how we get like so in this, our start s will remain as, and e will become a minus 1, because like this interval is like you can say this interval is overlapped, so we have to exclude this thing. So yeah, this is the first case. Now let's say second case, that is 10 comma 12. So 10 will lie something like here, and 12 will lie something like here. So in this, s is 10 and e is 12. So yeah, again in this you can see like this part is overlapped, so we have to remove this part. So in this, s become s equal to b plus 1. So s become b plus 1 and e remain e. So what is b plus 1? B plus 1 become 11. So it become 11 comma 12. And what is this, this was our 2 comma 6. And now another one is 14 comma 16. 14 comma 16. So yeah, 14 comma 16 is completely outside the range. Yeah, you can see that. Also yeah, there will be also one case in which the like area will be outside this range, like either on the left side or right side. So in this case 14 comma 16 look like here, 14 comma 16, so it is outside the range, so we can simply take this as same. So yeah, so you can see that like output for this is 2 comma 6 12, sorry. So here is 11 is in our like free time, so it will be 11 plus 1. Sorry, so it will be the 11 plus 1, that is 12, so it will be from 12 to 12. So you can see the this is the thing in this problem. So if you get this, now simply it's a simply if else condition to write the code about this thing. So yeah, this is the thing. And also there is a one case in which the completely lies inside. Let's take example something like if we have something like uh 8 to 10, like 8 to 10 completely lies in this range, so we can't get any answer. And if something like if we have from 1 to 20, if we have something like 1 to 20, it will look something like this. So we get something on the left answer and something on the right. So in this, our answer is from s to like s is start and e is end, like s comma a minus 1, and another part, second part will be the b plus 1 comma and. So yeah, these are the 5 cases. If you get this, it will be easy for you to write this answer. So let's now write, let's see the code for this. So you can see like firstly what I am doing, I am firstly sorting the array, and then this is a simple code to check if the array is like if the interval are overlapping or not. So I am taking like a start and end variable and storing the first value in it, and then start from second and check if the second value is overlapped with first. And also you can see why I write and plus 1 here, not comparing like because we also you can see like in this here, two interval touch if the second interval start immediately after the first one, like let's say example like 1 1 comma 2 2. So you can see that 1 1 comma 2 2 are not overlapped, but they are start immediately after the end of the first. So yeah, it means that they are also overlapped. So yeah, to handle this case I am writing and plus 1, and then I am will updating the end, because start will remain as same because the array is sorted. So yeah, so and will be updated either with this value or the end value remain with same value. And if the array is not like interval is not overlapping, I am simply adding into my vector, and then again make the start and update the start and end value. And also at last I am adding this thing, start and end, because we you can see that last one will always remain uh we are not entering the last one here, so we have to add it outside our loop. So yeah, so after that I am declaring a let me remove this code. After that I am declaring a simply a answer, like answer vector of vector for storing the answer. Yeah, and after that I am iterating this this vector t, and then I am declaring two variable like a start as a first value and as a second value. And yeah, now I am checking this five cases. Like first one is like completely overlapped. You can see that. Let me copy this thing and explain this in here. I hope it is visible, properly visible to you. So this is the first case, like what so this case will look something like this. Like we have something like a comma b, and we have as start before a, and after b. So you can see that I am checking if the start is less than a and is greater than b. It means that this a comma b, like the free time is overlapped by start and end time. So in this we get two array like something like this, from s to a minus a minus 1, and from b plus 1 to end, like you can see that. So these are the two part we are getting. This is the first case. Then the second case is like this. We have something like a comma b, and our s comma b completely lies inside a comma b. So yeah, you can see I am taking like start is greater than equal to a and end is less than equal to b. So it means that s comma is completely overlapped by a comma b. So in this we have to add nothing to our answer, so I am skipping this case. And the third case is this like this. We have something like a comma b, and our start will start something here and e will end like this. So yeah, you can see like a is greater than start and a is also less than end. So like something is overlapped here. So like left part is some left part is free here, and something is overlapped on the right side. So in this case we are getting answer as like as start comma a minus 1. So yeah, you can see that doing same thing here also. And the fourth case is like opposite of this. So we have something like a comma b, and our start from middle and end, like now um overlapping at left side and something at right side. So in this we get something like b plus 1 comma e. Yeah, you can see that. And else part is like there is no overlapping. If there is no overlapping, like if the like we have something like a comma b here, and s comma e lies on the left side or the right side. So yeah, in this case we are simply adding our adding start comma and interval to our answer. So yeah, this is for this problem. I hope you understand this problem. So yeah, so let's again submit this problem. So yeah, so if you have any doubts, so you can comment. I will try my best to reply to every comment. So let's now move to the fourth problem of this contest. So the fourth problem is like minimum time to reach target with limited power. So yeah, so you can read also read this problem. I will explain you in easy term like so this is a graph. In this problem we have given a directed weighted graph where we have given as like a UI, VI and TI. UI UI comma VI mean there is a edge from UI to VI, and TI is the time take time to traverse from U to V. If we traverse from U to V, it will take TI time. And also we have given an integer name as power and a cost array. And you are also given a source and a target, and we have to reach from source to target with a power units. So we have something like a power, and whenever we move from let's take example, whenever move in this we move from 0 to 1, like in 0 to 1, if we move from 0 to 1 the power required is 2, like 2. So initially our power was 4, it means that cost required to move from 0 to 1 is 2. So it means that we can easily move because our power is greater than cost. Yeah, that thing. And what we have to return in this case, we have to return the minimum time, like time required to move from source to target. And also we have to return another variable, what is the maximum remaining power. So in this problem we have to return two things which make it difficult, as it is a simple you can say Discastro's algorithm. So yeah, let me copy this image. And also copy this. So yeah, this is the thing. Now let's try to understand this problem, what they are trying to say. So we have given like edges. Yeah, you can see that there is edge from 0 to 1 with a time of 1. This is a time mention, like, and we have a power of 4 and a cost array and a source and destination. So source is 0 and the destination is our 4. So we have to move from source to destination with minimum power consumed and the minimum time. So yeah, so like you can see this is a kind of like we have to find this uh let's skip this power thing, like we have to maximize the power left. So if we skip this part, then it's a simple, like we have to find the shortest path from let's say it is a weight if we move from 0 to 2, it will take a 1 cost 1, 2 to 1 it will cost us 1. So yeah, we have to find the minimum path distance to reach this from source to destination, which is this Kastra's algorithm. So yeah, if you get this thing, I think you will be able to solve this problem, like. So let's see how we approach this problem. So one thing is we have to minimize the time. So for that we are using the discussed as algorithm. But how we maintain this power thing, let's see. So I hope you like if you know Discaster's algorithm, it will be easy to understand this problem, because I am not going to explain in that much detail like how Discaster's algorithm work. I will directly uh, explain using like I am priority queue and different things required to solve this problem. So yeah, you in Discaster algorithm we are going to maintain a priority queue. Let's say the priority queue will be of type this, like we are maintaining the time which we required, and another thing is the power, and the last one is the node, like which currently at which node. So initially the time will be the 0 and the power will be 4, and the node will be the node will something like a source node. In this case our source node is 0. So this is in our initially our this we add this entry in our priority queue. So after that we will try to use the algorithm and try to explore all different paths. So from here we can go to different path, like from 0 we can go either to 1 and either to 2. So let's say we are firstly going to 1. So if we're going to 1, we will pop this out and traverse like all the alternate, like from here from node 0 where we can go. So if we go from 0 to 1, the time required is 1 and our power become 2, because the to move from, if we move from 0, the cost is 2. So it will sorry, yeah, if we move from 0 the cost is 2 and our node will become 1. It will look something like this. And also we are going to next thing is like we from 0 we can go to 2 also. So again the time will become 1 because it was previously 0, and node like and the power become 2 and node become 2. So yeah. So now the from this like both has same value, but this has like in the last node value is 1. So in priority queue in Discasters algorithm we use min priority queue, so it will give this as a top. So again we will going to pop this out and try to traverse all the path from node 1. From 1 we are going to node 4. But you can see from if we are moving from 1 we need a power of 3, like yeah, but we have only power of 2, so we cannot move from 1 to 4. So yeah, we can skip this path. So after this we there is no another node where we can go from 1. So let's now skip backtrack this thing, and now from like as we are using queue there is no backtrack thing, but we were moving from 0 to 2. Then it will something like from 2 we can go to 3, and the in that case the time become 2 and then power become 1 and node become 3. And again we will pop this out, and from 3 we can go to 4 and the time become 3, power become 0, and yeah, and the node become 4. So again we are going to pop this out, and after popping out we can see that we have reached our target like 4. So it means that our answer we can simply return 3 comma power as 0 as our answer. But you can see that in this we get this as a time, we have to return a minimum time and maximum power left. But this will not give you maximum power left because we are simply maintaining just simply a power. So let's see, let's take some example in which I can explain you how this power thing will not work. So let's say instead of this we have something like 1 comma 5 comma 1, and we have something like 1 comma 2 comma 2. So as we are using the min priority queue, it will return this as our at the top, not this. But you can see we want to maximize this thing. So if we are taking this as a positive value, it will return a later. So instead of doing storing it as a positive value, we are going to make mark it as negative. So if we mark this as negative, minus 5 becomes smaller than minus 2 and it will return at top. So by doing this we can easily we can get our answer, because if we get the answer at this 4 we can simply return the answer. Because if we don't do thing like this, then we have to explore run the algorithm until our queue become empty. So so which can may give a TLE, because in this we have to explore lot of path. Because if we explore using firstly this, and then using this there may be chance like there may be a large tree before after this. So we have something like like if we are getting something like answer calculate for a whole tree using this -2, then we again have to calculate for -5 also, because it will always give us a better answer. So yeah, so this is your thing that we have to maintain. So else it's a simple discasters algorithm. So let me explain the code for this. So firstly, I am simply converting this edges to a adjacency list of pair, because we have something like edge from u to v, and we have also have time. So this is the that thing, and then I am declaring a priority queue. Like as we are storing three variable, I am declaring it as a vector of ll. Like by ll, I defined it as a long. However, you can see. Then it's syntax for declaring a min priority queue. Then I am also using a dynamic programming like a VR map. So it's a simple optimization. If you know Discasta's algorithm, you know, like we all in that we also maintain a distance array, but instead of maintaining simply distance array, we are maintaining a 2D vector in this for a like a power. You can see that size of n comma power. So let's see. Let's explain it how it is working. So what we are doing. So what we are doing in this is like let me explain it here. Like if we have reached a node 2 with a power of 3, there may be possibility like from here we can move something like this. There is a edge from here. We also reach to same thing like at we reach to node 2 with a power of 3. Then there is no fun of calculating answer from here to all the below child. So to memorize this thing, I am simply using uh, this DP. So yeah, so then I am simply pushing the initial value like time as 0 and a power to be a negative power, and then a source, and I am making the this DP value to 0. Yeah, also this will also help us in also one thing more. One thing more is that whenever like we explore this path using like we reach 2 at power 3 from here, and if we reach same like from here, there is something like path from here we reach 2 with power at 10. So it is always benefit like we explore this path instead of doing this, because we want to maximize the power. So yeah, that thing also we are also maintaining it. So you can see that source comma power, initially we are making this 0 for the source and source. So like if the source is equal to target, like if the source and target are same, in that case the time will be the 0 and power left will be the power. And then we are using a simple discasters algorithm, and we are taking the top element and popping it out and storing like making three variable like a time, a power, and a node. And I am checking if the node is equal to target, and then simply returning the time and the power. And as I am checking like this is these are simple optimization. Like I am checking like if the now I can if like you can see like I am checking if the DP of node comma power, like if we already reach that node with that much power in less than this time, then there is no need to explore this path, because like this path will not give us a optimized answer, because already the time is greater to reach the same thing. And similarly I am checking like if the power is like power left is less than cost of node, then it is like not possible to take that path. Also, I am iterating to all the children node of that node and calculating the new power and the new time. Like new power will become power minus cost of the node, and the new time become time plus the like to reach this node like time. And I am also checking like if the new power become 0, I am continue like skip this thing. And also I am checking like if the like if we have reached same thing and also with the same time or better time, then also we can skip this thing. Else we are going to update our dp state and push into our queue. And at last we are simply returning like -1, because if don't we don't get there is no path like in this like graph. So let's take it like in this graph, you can say the source is 0 and the destination is 3. So you cannot reach from 3 from 0. So yeah, in that case we have to return -1. So yeah, let's try to also submit this problem. So yeah, you can see like this problem is also working. So yeah, I hope you enjoyed this video. And if you like this video, please like and subscribe my channel. I will now regularly upload like lead code and thinking of also uploading code forces contest problems daily.